Okay. When you have the alkene and you want to add the Cl2 for addition of the mechanism or overall reaction. First of all, you need to know the overall reaction. When you're adding Br2, one Br would be added to one carbon, another Br would be added to the other carbon carrying the double bond. Same thing for Cl2. So what else you need to know is the mechanism of the reaction, and if this addition, it's a anti-addition, is it syn addition, is the addition Markovnikov or anti-Markovnikov? And please respond, because I'm sure you all want most out of this meetings. So what would be the addition? Markovnikov or anti-Markovnikov, or neither? In this case, thank you for your response. Okay. If it's a Markovnikov, that means the hydrogen would add, or electrophile would add to the least substituted, and the other one would add to the most substituted. But when you're adding Br2, both of them are the same group. So it doesn't matter if the first Br goes to carbon 1 or the second Br goes to carbon 2. So there is no Markovnikov or anti-Markovnikov discussion when you are adding Br2, or if you're adding H2. You would have the Markovnikov discussions or anti-Markovnikov discussions when you are adding like HBr, you're adding H2O, or if you're adding alcohol. You're adding Cl2, same thing. There is no Markovnikov or anti-Markovnikov discussions, because these two are symmetrical, or they are exactly the same, and it doesn't matter which Cl would go to the first or which Cl would go to the second carbon. Okay. So what is happening in terms of the mechanism for this reaction, the pi bond, so the arrow is going always from the electron rich to electron poor. So pi bond, when it comes to form bond with the Br2, since we already have the 2 electron from the pi bond, is not taking any electron from shared electron from Br. So basically, if you already have the 2 electron from the CC double bond, so when these electrons are coming in to form bond with the bromine, there is no need for this pair of electrons that is shared, because you already have 2 electrons from the carbon-carbon double bond. That's why this pair of electron is going to go with the Br. So basically, this Br does not bring any electrons, so it's coming as a Br plus. Is going to join the double bond with the B plus sign, so it's going to bring the plus sign in. So you have like a carbocation structure here. The plus charge is going to be shared between in the cycle, between the groups of the member of the cyclic system that we have. So formation of a triangle, keep that in mind. There is formation of a triangle here. And what happens when you have that triangle, the next piece as it's coming in cannot come from the same side, because it's hindered. Is not going to go from the top. In this case, is going to go from the opposite side of the triangle. And then since this carbon already has 4 bonds, you have 1, 2, 3, and 4. Because you have 2 hydrogens, you have 4 bonds on this carbon already. When you bring the bromide to this carbon, is going to add a 5th bond, and 5th bond would make this carbon very unstable. So the weakest bond will break. What is the weakest bond? Is the bond from the triangle, because if it's going to, as soon as it breaks, is going to give relief to the triangle, because triangle is going through angle strain. of the 60 degree, and it's not very easy for this to cover that. So what's going to happen, the bromine would break over the other carbon. And since there is a negative charge, and you have to pay attention, as I said before, when there is a negative charge and the positive charge in your molecule, it's going to cancel. So there is no further action. If this was a stereo specific, I mean, if you had the chiral center, you have to make sure that you are saying that you have your one of the BR is from the attached from the top, the other BR is attached from the bottom. This type of addition is symmetrical, so we don't have to talk about Markovnikov, anti-Markovnikov, but the addition is a anti-addition. So one BR from the top, the other BR from the bottom. The opposite side is attached. In case if you had the chiral center, then you have to say if this is like a R configuration or S configuration. In this example, because you have two hydrogen attached to each carbon, it cannot be chiral, and we don't have to discuss the stereochemistry of it. So why this triangle is forming? Because when you have the minus sign and the plus sign that you have here, they're close enough to form the bond. And since carbocation is very unstable, it's going to form the bond, and you get that triangle, formation of that triangle in the reaction, as a reaction intermediate. So you could have a carbocation that is an open chain, or you could have a carbocation that is a cyclic form. But since is carbocation unstable and the plus minus charge are very close to, is going to form the pair of unshared electron that you have on the bromine is going to form the bond and takes care of the plus charge. It brings the plus charge into a cyclic system. Same thing for addition of the chlorine. One chlorine would be added to each. A triangle also is going to form here. So is there any carbocation rearrangement in this case? In this case, and for every other reaction that there is a triangle formation as the intermediate, there is no carbocation rearrangement, because your plus charge or carbocation is engaged with in the ring, so there is no chance for shift. So anytime you have a intermediate that involves like triangle, there is restricted. So the plus charge is restricted in the triangle. So there is no rearrangement. So even though if you have the plus charge here and there would be possibility of moving from secondary to tertiary, but because of that triangle, formation of the triangle to begin with, as the intermediate is engaged in the triangle, is not going to shift. So there is no rearrangement, because these are the concerns. When you study these reactions and when you are studying for the exam again, you have to make table of each of the reactions. And for each of the reactions, you have to identify if the addition reaction is Markovnikov or is not Markovnikov. Is it syn addition or anti-addition? Is the reaction is going to involve carbocation? And if the carbocation rearranges or it doesn't rearrange. There are a couple cases that there would be no rearrangement even though you have carbocation, because you do have formation of that triangle. So whenever you see in the mechanism, you have a triangle. One is addition of Br2 and Cl2. The other one is oxymercuration-demercuration, which you have reviewed already. There is no rearrangement, no chance for rearrangement. Okay, formation of halohydrate. This is the solutions that halohydrate formation. This is the reaction that you're adding both water and halogen. First, the halogen is going to come in and form that triangle. Second, water would come in. And since the triangle is going to form, what's going to happen in this case? What's going to happen in this case is that water would go from the opposite side. And since the water would go from the opposite side, the addition, the type of addition is called anti-addition. It's the attack is going from the opposite side. So you have to remember, whenever there is a triangle, the other piece or the nucleophile is going to attack from the opposite side. So it's anti-addition. Now, addition of Br and OH, that makes the halohydrine and OH. Now you have to talk about, is this going to be Markovnikov or anti-Markovnikov? This addition is going to be Markovnikov addition, and Br is treated like my God. It took this long.
Sorry, Professor, I didn't want to cut you off.
Okay, what do you see now? Do you see the
I still see
halohydrine or oxymercuration?
oxymercuration.
So, oh gosh. It was recording the right slides. Okay, so when you bring in the Br first, and then you bring the Br first, and then the water, the Br is going to form the Br2 is going to form the triangle, and whenever is formation of the triangle, the water would come in, or the nucleophile, which is the second piece, would come in from the opposite side. So when it comes from the opposite side, the addition is going to be anti-addition. So now in this case, when we are adding Br and OH, we have to discuss, is it going to be Markovnikov or anti-Markovnikov? Is discussion of Markovnikov, anti-Markovnikov is relevant because the Br is treated like hydrogen. So for addition of the halohydrine or formation of the halohydrine, when we are adding the Br and OH, Br will add to the least substituted carbon, and OH will add to the most substituted carbon. So in this case, when you have the Cl and OH, so when you are adding halogen and water, you would add Cl and OH. Cl would add to the least substituted carbon, and OH would add to the most substituted carbon. So when you are studying, you have to pay attention to these details, even if the questions like is multiple choice is looking for your understanding that if this addition is going to be anti-addition, is it going to be Syn addition? Is it going to be Markovnikov or anti-Markovnikov? As I said in the previous slide, when you are adding Br2, so Br2 only, there is no discussions for a Markovnikov or anti-Markovnikov because both of the carbons would take, both carbons would take the Br. So there is really no difference which carbon would take the Br. But in this case, when you have the OH and the Br, you have to pay attention that Br is going to go to the least substituted and OH would go to the most substituted. And again, is going to be the stability. What determines that Markovnikov product is the stability of the intermediate. So your intermediate is a triangle with the plus charge. Now the plus charge is going to be more stable on the more substituted carbon. That's why H2O goes to the more substituted carbon. And the Br will break over the other carbon. So the net result would be addition of the Br and OH, and it is anti-Markovnikov, and anti-addition and Markovnikov. It would be Markovnikov anti-addition. So in this case, we have both Br and H2O. You will get Br on one and OH in the other. In the other carbon. The addition also is anti, because the formation of triangle, the addition is anti, meaning that from opposite side, but it's Markovnikov addition. Oxymercuration, demercuration. What do you know about oxymercuration, demercuration? Or what you need to know to making sure that you have the, making sure that you know the reagents. If the reagents are separated by numbers, that means that you're adding this set of numbers first, this set of the reagents first, that is number one. And on the next step, you add the sodium borohydride. So first, you add the mercury 2 acetate with water. THF is just a solvent. So make sure you memorize your reagent. If you don't memorize your reagent, you will not do well on exam for chapter 8. And your next exam is basically very heavy on chapter 8. And chapter 8 has a lot of reactions. So do not wait for the day before the exam. Make sure you memorize now. You have to memorize all the reagents for chapter 8. And the net result for oxymercuration, demercuration. So what is this? Oxymercuration, demercuration is indirect addition of water. So you have to learn it this way, is indirect addition of water. That means that you are adding H and you're adding OH. And what type of addition is this? Is a Markovnikov addition. So is a Markovnikov addition. So you're adding H and OH. H will add to the least substituted carbon, and OH will add to the most substituted carbon. The addition, is it a Syn addition or anti-addition? That means that if you had a carbon that it was chiral, would the OH would be in the same side that the hydrogen was added, or is in opposite side? That is indicated by the mechanism of this reaction. Again, for reactions that you do have formation of a triangle, then it's easier for you to memorize that is going to be anti-addition. So if you look at the mechanism for this reaction, for the steps, you see that a triangle is going to form. And when the triangle forms, like you have the Hg, OAC plus in the triangle, that's one of the steps giving you a triangle, then the addition is going to be anti-addition, okay? It's going to be is not a Syn addition. Okay. So you need to know your reagent, you need to know the reactant and the reagent and the product. Just know that oxymercuration, demercuration is just like hydration, but this is indirect hydration. Why do we have to go through indirect hydration if we could just add water and sulfuric acid? Remember, if you did direct hydration, your product was a rearranged product whenever possible, because carbocation forms, it goes through rearrangement, and then it gives the rearranged product. When it comes to oxymercuration, demercuration, the intermediate that forms is a carbocation with restricted plus charge in the plus charge is restricted in a triangle, and whenever this is the possibility or this is the part of the mechanism, there is no chance for rearrangement. This is the benefit of oxymercuration, demercuration over direct hydration. So first of all, you need to know your reagent. Second, when you have choice of 3 different methods for hydration, which one are you going to pick? The problem with direct hydration, meaning just addition of just water with acid is going to be the rearrangement. That's the problem. The oxymercuration demercuration would do the same thing, would add H and OH or add water, but removing the chance for rearrangement. The addition is a Mark addition, is a Markovnikov addition. What does it mean? H will add to carbon with more hydrogen, and OH will add to the carbon with the least number of hydrogen or more substituted carbon. The addition is also anti-addition because of this formation of a triangle. So formation of triangle, first of all, prevents rearrangement, carbocation rearrangement. Second, the nucleophile has to come from the opposite side. And when the next step, so when you have your oxymercurated product, on the next step is going to be reduction. Basically, what reduction does, it replaces this mercury acetate with another hydrogen. So that's like this is the fast and simple step. What's going to happen is that sodium borohydride is a reducing agent or provides hydrogen or hydride ion and is going to replace this group. That's all is happening on the next step, because we want overall reaction to be addition of OH and H. And you notice that the H is added to CH2 and OH is added to CH. And you have the other explanation. Don't know. Alkoxymercuration-Demercuration. In this case, for alkoxymercuration-demercuration, instead of water, you're adding alcohol. And when you add alcohol, you add H. And if you look at I hope that you go back and review the other PowerPoint that I actually recorded in your class. I said when you're adding alcohol, like methanol, you would add H and you would add CH3O. For Markovnikov addition, H will add to the least substituted carbon and OCH3 will add to the most substituted carbon, and that would give you your product. So alkoxymercuration-demercuration. This is going to also avoid rearrangement. So there is no rearrangement in this case also. So when the carbocation forms, is not going to rearrange, and is a Markovnikov addition, and H adds to lower or least substituted or more hydrogen, and OCH3 would add to the other. Any questions? Let me check the chat. Okay, if you don't see the chart for the reagents, you are going to make a chart for reagents. The first slide that it was in this chapter, it gave you the list of or summary of the reaction, and it gives you the reagent. But the best way to have a list of reagents is to prepare flashcards. So on a flashcard on one side, you would write the name for reactions. Let's say oxymercuration-demercuration. And then you have to list a specific outcome. The addition is going to be Markovnikov addition, okay, for oxymercuration-demercuration. The net result is formation of alcohol because you're adding water. You're adding H and OH. The final product would be water. The addition is going to be anti-addition because the triangle forms and is going to be a one on So one would add from the top, the other one would add from the bottom part, because of the formation of that triangle. Then you go to the next flashcard, and then on the other side of the flashcard, you just write a complete reaction with an example, a specific example. And you have to memorize the reagents on one side and understand the reaction. Okay, so there is no list for the reagents. You have to come up with them. They are, every time there is a new reaction, that you get the list of the reagent that is separated by numbers or separated by comma. If it's separated by number, that means two-step reaction. If it's separated by comma, that means you're adding both of them in the same step of the reaction. Questions? Sure, you could always ask, but you come up with those flashcards, you come up with the table in your notes, because when you watch the video, you need to take notes, just don't watch the video, and then come up with the list. And when you do problem solving, for every problem that you have in the assignment folder or the assignment file, there's new set of reactions. List them all with the name of, and kind of, it should become like very natural. Like if someone, you're at the, any line, someone asks you, have you heard about oxymercuration? Then you have to just tell the story. Yes, oxymercuration, demercuration is addition of water to alkene. So you have to tell the story in order for you to remember enough to take the multiple choice exam now, for final, for later. But if you can't tell a story about it, you cannot say that, okay, this addition, by the way, is going to be Markovnikov addition. If it's oxymercuration, demercuration, the advantage of it is that there is no rearrangement, carbocation rearrangement, just like we had for the direct hydration. So that's the advantage. The addition is Markovnikov addition, so be careful. You have to add the hydrogen to the carbon that is least substituted, or the carbon that has more number of hydrogen. So if you are able to tell the story, you do well on the exam. But if you don't memorize your reagent, you don't memorize the directions on all these directions, if it's going to be Markovnikov or anti-Markovnikov, I'm repeating now, I'm saying now, and it's also recorded in the other videos. And you watch the video, and you have to come up with the list for yourself. And I just like to say it. I know that you guys studying hard, but studying efficient is better than studying hard. When you're studying hard and you're reviewing one reaction 3-4 times, it's best to look at the reaction once, replay the video, and start writing all the specifics about that reaction. What type of addition is this? Okay, epoxides, formation of epoxide is another type of reaction that you have to be worried about. Epoxide, they look like this, carbon, carbon. So if you have this triangle part of the molecule, the functional group is called epoxide. If you want to go from alkene to epoxide, this is the epoxide. If you want to go from alkene to epoxide, all is happening that you are inserting oxygen here, and you are making that triangle, and you take this as a final product. There is no O+ here, it's just the oxygen. The reagent for that is peroxy acid. What is a peroxy acid? Peroxy acid, so if you have carboxylic acid, is a CH3COOH. This is very stable compound. If you change that to peroxy carboxylic acid, is going to be very unstable. This is peroxy OO single bond, just like hydrogen peroxide that you keep in brown bottle in the dark, low temperature for it not to decompose because it's very weak bond. Okay, if this is a peroxide, it will break. Then you have the is the same situation here. This bond is very weak. Just think about this proxy acid that has extra oxygen compared to a more stable molecule of that. Carboxylic acid, this is a proxy acid. Proxy has extra hydrogen. If you think of this extra hydrogen, it makes this molecule unstable and is going to jump and be just added to this carbon-carbon double bond. You kind of make your life easier. So you lose the proxy acid is going to lose that oxygen to the double bond, and it forms a triangle, and that ends up with one oxygen, which is the more stable form of it, and it is carboxylic acid. There is no Markovnikov, anti-Markovnikov discussion here. There is no syn or anti-addition, because all you end up with is this triangle, and that is the final product. Okay. Borane, these are like a type of electrophiles that you could also add to your list. Anything that is electron deficient is electrophile. Hydrogen ion is electrophile, carbocation is electrophile, borane is electrophile because it doesn't have its octet satisfied. It's one of the exceptions that you learn in 1045 that has only 6 electrons. For the BH3, there's no additional electrons here. So it's a Lewis acid, and it is a electron deficient. So it acts as an electrophile. In hydroboration oxidation, that's another reaction which you have to create a new chart for this or new flashcard for this to remember and memorize it. It is very unique, and it gives you anti-Markovnikov product. This is one of those cases that you get anti-Markovnikov. And if you remember from previous video that recorded in your class, or you look at the recorded videos, I say as a hint, whenever you see H2O2 involved in a reaction, in addition reaction, know that that is going to be anti-Markovnikov. What it means is anti-Markovnikov, instead of hydrogen being added to CH2, is added to CH, and OH is added to CH2. This is a this is a direct hydration, is comparing direct hydration with the indirect hydration or hydroboration oxidation. I didn't look at the reagent, sorry. So in a direct hydration, you get Markovnikov addition. That means H is added to CH2. But for hydroboration oxidation, H, first of all, what is hydroboration oxidation? You have to learn this as the indirect method of hydration. Is hydration, that means you're adding H and OH, but is indirectly. Why do you have to do indirectly? Because you don't want carbocation rearrangement. And in this specific reagent, you want to make sure that is anti-Markovnikov because you want to make a primary alcohol. So with the primary, to get the primary alcohol, OH must add to the CH2, and that is something new. This is anti-Markovnikov. A lot of reactions, we looked at they were Markovnikov, but this one is anti-Markovnikov. What else you want to know about this is that this reaction is the Syn addition. That means when OH is added from the bottom, H is also added from the bottom. So just know that this is not the anti-addition, just in case if you have a chiral center. Two-step reaction. And how do we know it's a two-step reaction? Because the reagents are separated by numbers. If they are separated by comma, they are added to the same step. If they're separated by number, or if you have like this, 2 arrow in a reaction, that's two-step reaction. So in this case, based on the mechanism of the reaction, basically a bridge is going to form. Hydrogen will add to the least, the carbon with the least number of hydrogens, and the BH2 would add to the other carbon. And the next step to other carbon, I mean by the more number of hydrogens. Okay. Thank you so much for the comments, but I give the credit back to yourself because you actually watched the video before taking the quiz. That's why. Okay. If you want to make sure that it's clear every time, watch the video before. So I give the credit back to yourself. This means you have watched it before. You have, and this is the second time that you can see it. You could do this by watching the video 2 times, but the good thing is that you can actually ask question or make comments like that you actually are getting. That's perfect. Okay, so hydroboration-oxidation, addition of H and OH. We already added the H in this step because we know that H is added to the more substituted carbon, and the BH2 is added to the least substituted carbon. On the next step, we have to change BH2 to OH. So you are bringing OH, you are bringing H2O2. So it's an oxidizing agent, okay? So H2O2 is kind of oxidizing agent that is going to replace BH2 with hydroxide. The alkyl borane, why do we use alkyl borane? If you see this reagent, please do not think that this is a different reagent. Now you have to memorize a new set of reagents. It's the same thing, but it's going to be more stable than if you had just the BH3. BH3 is very unstable. It forms either a dimer or to be more stable, or if you are using alkyl borane, is going to make it even is going to be easier for it. So you have the H added and the borane added, and moving to the next step because this is repeating. The BH2 will change to the OH group. So on the first step, you are adding H and BH2, and the next step, and the second step, so you are going to add here H, and then you add the BH2, and the next step, you're replacing the BH2 with OH. That's kind of a shortcut to it. So in hydroboration-oxidation, you want to know the set of the reagent, BH3 THF, hydroxide, hydrogen peroxide, and water. So this combination is called hydroboration-oxidation. The reaction is indirect hydration. The net result is addition of H and OH. The addition is a Syn addition. The addition is anti-Markovnikov. So that's what you want to find out, or you want to remember or take on from this reaction. So what all this is telling me that you have to add the hydrogen to this carbon and the OH to the first carbon. And that's where you get this product. There is no chance for rearrangement. So regardless of the neighboring carbon, if you have a hydride or you have a methyl that is possible for shift, there is not going to be a shift, and it's going to be just stay. The carbon skeleton does not change. Even if you have like a T-butyl group here with 2 methyl group, still the carbon skeleton is not going to change. So you're just adding the OH to the least substituted, and H to the most substituted. And they are both added from the same site. This is known as the Syn addition. Next type of reaction is hydrogenation. In hydrogenation, you're adding two hydrogen, one hydrogen to one carbon, another hydrogen to other carbon. Do we have to talk about this is Markovnikov or anti-Markovnikov? The answer would be no, right? We don't have to say this is Markovnikov or anti-Markovnikov because we don't have H and OH. We don't have asymmetrical addition. It's a symmetrical addition. You're adding H to one carbon, H to the other carbon. But this addition is going to be Syn addition. It's going to be Syn addition. And when it's going to make the difference is like if you had an addition of hydrogen in chapter 5, that one of the carbon becomes chiral, then it makes a difference if the hydrogen is added from the top or from the bottom. But as long as you know that is added from the same site. The addition is Syn addition. The net result is saturation. This is like is going to saturate. When you have alkene is unsaturated, it requires more hydrogen to saturate, so it becomes saturated. So the platinum, palladium, or nickel, either one of them would act as a catalyst. No, there is no difference between them. So you can use either one of them. It's separated by 3 different reactions, just to emphasize that you can use either one of them. But you could say that you can use either platinum or poison platinum. So you mix it with charcoal. So it's like a platinum absorbed on the on the charcoal. So basically, what it's saying that your catalyst is like a heterogeneous catalyst. So it's like a solid piece. And you bring your CC double bond that attaches here. Hydrogen is going to attach here. So you have the H2. And then one hydrogen is going to bond for one carbon. The other hydrogen would bond to the other carbon from the same site. So it's a Syn addition. Oh, this picture is better. So you have the hydrogen, is nicer picture. You have hydrogens on the surface of your catalyst, and then you bring the alkene. So one hydrogen would attach to the carbon from one side, and that would be at the surface of the catalyst, and the other hydrogen would attach to the other carbon at the surface. Because the hydrogens are at the surface, and this addition is happening on the same side of the molecule, the overall addition is going to be Syn addition. And it's the net result. Okay. Just have to move this to be able to see. Okay, you can probably see it there. So addition of this is the summary of the reactions. So you have the summary of the reactions, and you had, so this is the slide that you were talking about, 46, but you said 48, right? Do you have any questions about this slide? So what you want to know about in the summary of the reaction, when you are adding water, like direct hydration, that means the acid catalyzed reaction or addition of water. So you just have to list the items that we were talking about. This is going to be Markovnikov addition, is going to, there's a possibility for rearrangement. And is this a Syn addition or anti-addition? Is going to be mixed. And why is going to be mixed is not a Syn addition or anti-addition, because when you have a carbocation forming as intermediate, that means it has a p orbital that is perpendicular to the surface of the, or to the center of the carbocation as a p orbital. Now your nucleophile, which is the OH or OH2, is coming, it can come from the top or from the bottom. So it's going to be 50-50. So 50% of the time the OH goes from the top, and the 50% of the time the OH goes from the bottom. So you will get like a mixture of the product. You're not getting a specific stereo-specific product. Addition of alcohol, same thing, except that you're adding H and the OR. Addition is a Markovnikov addition. To avoid that rearrangement, you can do indirect addition of water, and that could be oxymercuration-demercuration for Markovnikov and hydroboration-oxidation for anti-Markovnikov. If you want to add alcohol, it's Alkoxymercuration-Demercuration. This is also Markovnikov addition. Okay? So you have Markovnikov addition. No possibility for rearrangement. That's the advantage of this over this one. Otherwise, you wouldn't spend the money on the, it's much cheaper just to use the acid. Any questions? So if you're adding Cl2 or Br2, this means there is no discussion for Markovnikov or anti-Markovnikov, but if you're adding Br and OH. Hydroboration-Oxidation, anti-Markovnikov. So you need to know the reagent. So this is a good place when you go to the summary, is a good place for you to list and rewrite it a few times. Pay attention to the reagents that you are using in order to get the, okay. I think this was a question on the quiz. So you just fill in these reagents as a practice, do it again, because you will see this or very similar on the exam as well. Okay, similar. What are the reagents that you should, fill in? What do you have to see? If this is your reactant, CC double bond, what is the change? You're adding Br2, so you just have the Br2 and the heat. But if you're adding, in this case, you're adding H and Br. So you have to compare the reactant to product and see what is the, when you are adding OH and Br, the addition is Markovnikov addition. The reagent would be Br2 and H2O. Okay, I'm trying to look for that. So the reagent here is a Br2 and H2O. So you're adding both Br2 and H2O. Addition is a Markovnikov addition. That means Br is added to the least substituted carbon and OH is added to more substituted carbon. Then we have the hydrogenation and everything else, because you have these already in a couple of the slides. So for cyclization reaction or formation of cyclopropane, basically you have a CC double bond that you can change that to this epoxide, or you can change that to cyclopropane. In order to change the CC double bond to cyclopropane, all you need is a CH2 instead of the oxygen. You bring the CH2. So what you need to know is the reagent, what reagent you would use to add the CH2. The name of the reagent is the iodo-methyl zinc iodide and is written like this. Iodo-methyl zinc iodide is an ionic compound. The zinc takes the plus charge. In this case, this would take the negative charge or takes the pair of electrons. And that's all you need to know. What is your reagent? Your reagent and then the product. So this iodomethyl, okay? The iodomethyl zinc iodide is going to provide the CH2 to come in and form the triangle or cyclopropane. Whatever is attached to these groups is going to stay. So it doesn't have to be like a simple cyclopropane. It could be a long branch, but you are making a cyclic system in there. These reagents are not used too often, okay? But just just to recognize that is going to give you a cyclic or cyclopropane, and if it's the methyl iodide with zinc and copper chloride, it would give you simple CH2. But if it's the bromoform, CHBr3 is going to give you CBr2. So you have the CBr2 added, is not the CH2. It's basically memorizing the reagent and knowing that is going to add a carbon. And in this case, when you have the Br, it's going to be 2Br added to it. But for the iodide, it would just be simple CH2. There is no iodine added. So we talked about the formation of the epoxide already. And now opening of the epoxide ring. The opening of the epoxide ring is going to, you have to bring a nucleophile. It can be in acidic solution or it could be in basic solution. That's the only part that you have to pay attention to it. So if you add water to the epoxide ring, okay. So the one that the reagent that we use is always peroxyacid. So this is the peroxyacid. So if you just say RCOOH, that is acceptable. Okay, is a peroxyacid, or you would recognize this is a peroxyacid. So when you are using the peroxyacid, is it's the reagent that would change the CC double bond to epoxide. Okay, everything that is attached, it will stay attached. So you don't worry about changing anything else. All you have to do, add this oxygen to it. Now, if you have the epoxide can further be opened because these are not very stable. You can add water to it. You can add alcohol to it. You can open the ring. The ring opening of the epoxide, it can take place in acidic solution. It can take place in basic solution. So if you add water, the net result of adding water in this case is going to be adding H and OH. So let's say you want to add water to this. You would add H and you would add OH. What would take the H from this molecule? Can anyone tell me which one would take the H? Would the oxygen take the H or the carbon would take the H? Because when you bring the H and OH, it's going to break the ring, okay? It's going to break the bond between oxygen and this carbon. One would take the hydrogen, the other one would take the OH. What is the common sense? Which one would take the oxygen? Oxygen would take the OH or H? Response, chat, Mike, use one of them. Opening the epoxide ring, O will take the hydrogen, okay? Very good. So opening the epoxide ring, that means that you are going to break the bond between oxygen and carbon. That's what it means. You don't break the carbon-carbon. That's very hard to break. But this is the ionic bond and is easier to, is more covalent, more polar bond, and is easier to break it. When you break it, you notice that oxygen has higher electronegativity compared to carbon. So oxygen carries more negative charge and carbon carries more positive charge. And hydrogen is a plus and OH is minus. So if you look at these like a bigger picture, when you look at this bigger picture, hydrogen is going to be added to the oxygen because you have more negative charge here. And OH will add to the carbon because you have a positive charge here, okay? What would be the overall product? So you have your carbon-carbon, the O would change to OH, and the other one would gain, the other carbon will take the OH. This is called diol, diol, 2-alcohol, okay? 2-alcohol functional group is added, is added. And the addition is going to be anti-addition. Why is going to be anti-addition? We do have a triangle, so this addition is going to be anti-addition. It's going, if the oxygen breaks on the, if the water comes from the bottom, the oxygen breaks over the other carbon and stays on top, so it's anti-addition. So opening of the epoxide ring with water will give you diol. What happens if you bring alcohol? Then your OH would change to OR. Okay, OH will change to OR, and that's going to happen OR. So basically, you would get the oxygen OH, and you would get the OR, which is like you have an ether and OH group in the same molecule. So opening of the ring or hydrolysis, that means adding water. Okay. Another reaction of carbon-carbon double bond is reagent that is used or formation of a diol, or another way to prepare diol is adding osmium tetroxide. When you add osmium tetroxide, the net result would be formation of a diol. And just know that this addition is also a Syn addition. Okay? The addition is a Syn addition because you don't have the triangle, but you have a pentagon. It's kind of a bridge. So the addition is going to take place from the same side. Okay, I'm not worried about this mechanism because it's just one simple reaction, addition of a OH. So don't worry about the mechanism for it, but just know that this intermediate, because it's like a bridge, is going to give you a Syn addition. The product is formation of diol. Both OHs are attached from the same side. Let's say if you're dealing with the final exam, and then we combine this reagent and with the R and S. So what would be the product? The product would be R product or S product on carbon 2 or carbon 3. You have to pay attention that this is a Syn addition. Both OHs are added from the same side, and then decide is it R or S. So the high OHs are added from the same side. So your product is going to be a cis product whenever possible. Like if you have a cyclic system, you have the cis or trans. For this one, for open chain, you don't have cis or trans. But in case if it's a chiral center, it's going to be S or R. But for cycloalkene, when you add the OHs, it's going to give you a cis product. Questions? Okay, a last technique or last reagent that can give you diol is cold permanganate. If you use hot permanganate, it would cleave this off. But for cold permanganate, if you are using cold permanganate, it would only add OH to each carbon. And this addition of the OH to each carbon, it's not going to be a Syn addition. is a mixture. Okay? You could get Syn or the other one, anti-addition. If the permanganate is hot, after the glycol is formed, then it would be oxidized even more. Permanganate is a strong oxidizing agent. Definition for oxidation in organic chemistry is add oxygen or remove hydrogen. So if permanganate is a strong oxidizing agent, is going to add oxygen. So it can add, if you use a weak oxidizing agent like cold permanganate and dilute, when you are adding this water here, and if it says concentrated and warm, concentrated and warm makes it a strong oxidizing agent. Dilute and cold is going to make weak oxidizing agent. So in a weak oxidation, you would add only OHs. In a strong oxidation condition, you would add CO double bond to each carbon. So basically what you do, you break through carbon-carbon double bond, and you add CO double bond to one side, CO double bond to the other side. This is known as oxidative cleavage. You cleave it and you add oxygen. What's your reagent? Is concentrated hot permanganate in acidic or basic solution. Okay, so it's going to be concentrated, or heat is involved. So what is happening in this case? Oxidative cleavage. So as soon as you see this hot permanganate, I just call it like hot permanganate, is a oxidative cleavage that would cleave and add CO double bond on one side and CO double bond on the other side. C exists already, you just add the double bond O. So you would get a ketone, you would get like a aldehyde, you would get, if you have aldehyde, okay, if you have aldehyde, the aldehyde is going to further oxidize because you still have another hydrogen attached to the carbon that can be oxidized. There is room for addition of oxygen, and it will add. This only happens if you add hot permanganate or a strong oxidizing agent. So aldehyde does not stay as aldehyde, it would go to carboxylic acid. But if you have ketone, it will stay as ketone because you cannot oxidize ketone further. In order to add oxygen, you must have a hydrogen attached to the carbon, where aldehyde has that hydrogen. So you can do further oxidation. In this case, if you look at it and compare what would be the final product, okay, if you're worried about the final product here, this carbon here is attached to two other carbon, so it's going to give you ketone, and that's what your ketone is. The carbon on the right side is attached to one other carbon only and is attached to one hydrogen. So we have a hydrogen and another carbon. If that is the situation, the final product of this is going to be carboxylic acid. If it's a CH2, it will change to CO2 with the hot permanganate. So these examples, they cover, each one is covering like a specific case. When you have like di-substituted and mono-substituted, one substitution is on one side, that would change to finally carboxylic acid. If you have two substitutions and attached to this carbon, it will stay as a ketone. If it's a CH2, it would change to CO2. This is happening with the hot permanganate. Okay, I don't see new comment or questions. I just want to make sure that you are fine. Do you have any questions? A lot of reagent, a lot of many reactions, and your responsibility is to memorize the reagents and know the reaction by name. oxidative cleavage. You have two types of reagent for that. One is permanganate and the other one ozone or ozonolysis. Okay, it is ozonolysis, and the only difference is that with the ozonolysis, if you use dimethyl sulfide as the solvent, with the dimethyl sulfide, so we have a CH32S as the solvent. If this solvent is used, aldehyde, if aldehyde forms, would stay as aldehyde. It does not go to carboxylic acid. So you want to look at the differences between ozonolysis and hot permanganate. Both of them would cleave and add CO double bond if you have hot permanganate or ozonolysis. Hot permanganate would change the aldehyde to carboxylic acid, but if you do ozonolysis and you use dimethyl sulfide, that's a big difference, okay? If you use dimethyl sulfide in ozonolysis, your aldehyde would stay as aldehyde, does not change to carboxylic acid. Questions? So basically in the ozonolysis, your ozone, which has 3 oxygen, 1 oxygen go to 1 carbon, the other oxygen go to the other carbon, and the third oxygen is not going to oxidize the aldehyde, but it will oxidize the solvent from dimethyl sulfide to dimethyl sulfoxide, which is DMSO. You probably heard about DMSO in aprotic solvent, polar aprotic solvents, and that's the structure for it. Questions? No questions? Did I set up the quiz already for you? Or I didn't? I don't know I set up the quiz for you or not. June 10 and 9:30. So are you ready to take the quiz?